one more example for brute force is exhaustive search. In exhaustive search, we are finding the solution for combinatorial problems. Here combinatorial problems which involves combinatorial objects such as permutations, combinations, or subsets of a set. In this method, first you are required to generate all potential solution in a systematic manner. Then you are required to evaluate potential solutions one by one and disqualify infeasible ones for an optimization problem, keeping track of the best one found so far. When search ends, you will find the solution for the given problem. For very first example here is traveling salesman problem. So when I say combinatorial problem, it involves permutation, combination, and subset object I told you. So permutation, finding the permutation of a given number n is n factorial. Even combination is also, you know, the formula here is NPR is nothing but n factorial divided by n minus r factorial into r factorial. It's almost factorial only. If there are n elements in a set, total number of subset is equal to 2 power n. So as n value increases, complexity grows factorially or exponentially. So one such example is traveling salesman problem, wherein it involves permutation object. The problem statement is like this: given n cities with known distances between each pair, find the shortest tour that passes through all cities exactly once before returning to the starting city. That means a person has to start the tour from a city, say A, and he has to visit through remaining all the cities exactly once, and he has to come back to the city with which he started the tour in such a way that total tour length should be minimized. This is the problem. For that, you are required to find out the Hamiltonian circuit. Hamiltonian circuit is nothing but, for directed or undirected graph, you are required to visit through all the vertices exactly once is Hamiltonian path. Hamiltonian circuit or cycle is a Hamiltonian path that is a cycle. Example here is this graph I have taken here. This is from the textbook Anani Leviton only. So here 4 cities are there. Assume that the salesperson starts his tour from city A. So he has to visit through remaining all cities, that is B, C, D, exactly once, and he has to come back to city A. So how many possibilities are possible for him? So start with A. He can go to B, C, and then D, then he can come back to E. This is one option. Like that, remaining is 3, so 3 factorial, that is BDC, then A, from A, C, BD, then he can come back to E. So tour length is also calculated here from A to B. Tour length, edge weight is 2, B to C, that is 3, then C to D 7, and D to A 5. Total tour length is 15. So like that, there are 6 possibilities. Here 4 cities, 6 ways, 6 feasible solutions are possible. From that, the optimal one is this tour, one which is having the minimum tour length. You all know that for any optimization problem, feasible solution is one which satisfies the constraints of the problem. Optimal solution is nothing but the solution which satisfies the objective of the problem. The objective here is to optimize the tour length. So this is the solution optimizing the tour length. Feasible solution is one which satisfies the constraints. Constraints of this problem here is a traveling salesman person has to visit through all the cities exactly once, and he has to come back to the city with which he started the tour. That is the constraint. Look at here, all this is satisfying the constraint, and we have calculated the tour length. These two tour, that is the first one and the last one, is having the minimum weight. So this is an example for exhaustive search, because as n value increases, even the complexity grows factorially. Now it is 4 cities. The complexity is theta of n minus 1 factorial. If there are 10 cities, then imagine 9 factorial feasible solutions you have to find. From that, you are required to choose the optimal solution. So which is exhaustive search approach, right? Because first you have to generate all possible feasible solution. From that, you are required to choose the optimal one. Next example here is knapsack. Here you are required to find out most valuable subset of items that fit into the knapsack. You have given with n items with weights W1, W2, etc. Wn, and values. The corresponding values of the items is given like this. Capacity of the sack is capital W. Now you have to fill the sack in such a way that value should be maximum. So you have to earn the maximum value. For that, one instance of the problem is given here. 4 items with capacity of the sack is equal to 16. So in order to find the solution, generate all possible subsets of 4 items. So all possible subsets of 4 items is 2 power n. That is 2 power, for this example 4 items are there, 2 power 4, that is 16. When you consider the first item, total weight is 2 and the value is 20. When you consider second item, total weight is 5, then value is 30. 1 and 2, total weight like this, and value 1, 2 and 3. Look at here, 2 and 3. 2 and 3, weight is 5 and third item weight is 10. Total weight considered in the sack is 15, and which is less than the capacity of the sack, and total value what you are going to get is 80. So like this you have to generate all feasible solution. From that, you have to choose the optimal one. The optimal one here is one which has got the maximum value, because the problem statement is like this. You are required to find out most valuable subset of items that fit into the sack. So most valuable, that means generate all possible subsets, find out which are all feasible. Feasible means total weight of the items should be less than the capacity of the sack. Capacity of the sack is given. It must be equal to less than total weight of the item should be less than the capacity, that is WO. So in this case, this is the example for not feasible. 1, 2, 3. If you want to consider 1, 2, 3, it is 2 plus 5, that is 7 plus 10, 17. Okay, 17 cannot be fitted into knapsack with capacity 16. So this is the example for exponential problem, because as the n value increases, the complexity also growing exponentially, because here 4 items, 2 power 4. If there are 5, 2 power 5, 2 power 10, it is 1024. From that you are required to choose the optimal one. Next example for exhaustive search is assignment problem. In assignment problem, this is also an example for combinatorial problem, and here you are finding the permutation only. There are n people who need to be assigned to n jobs, 1 person per job. The cost of assigning person I to job J is Cij. If you assign ith person with jth job, then the cost is Cij. For example, in this, person 1 with this job 2, the cost is 3, like this. Person 3 with job 3, person 3 with job 3 is cost is 4. You are required to find an assignment that minimizes the total cost. Let me repeat once again the problem statement. N people is to be assigned with n job. Constraint of the problem here is 1 person, 1 job. Objective is to minimize the total cost. This is the objective. So for that, you are required to generate all assignments. Okay. So like take the example here. This is the cost matrix given. How do you find the solution? For this, you have to find out all permutation of these 4 jobs, that is 1, 2, 3. Total permutation is 4 factorial, that is equal to 24. So find out the total cost when you make the assignment according to the permutation. From that, you have to choose the minimum cost, minimum total cost. We'll take one example. First permutation is 1, 2, 3, 4. So that means first person with this assignment, if I write 1, 2, 3, 4, meaning first person with the first job, second with second, third with third, fourth with the fourth. This indicates the job number. Person will be taken in the order. So first person with the first job is 9, second person with the second job is 4, third with third is 1, cost is 1, fourth with fourth job, the cost is 4. Similarly, I'll take randomly this assignment. First person with first, second with fourth job, third with third job, and fourth with the second job. First person with the first job, that is 9. Second person with the fourth job, second person with the fourth job is 7. Third person with the third job is this one, and fourth person with the fourth person with the second job is 6. Total cost is 23.